Okay, so the first question is, this is your function, and they've asked you to basically integrate it. So you're finding the integral. So that, remember, we add 1 to the power and divide by the new power, so that's okay, so we're adding 1 to the power, so it becomes 3 divided by that new power. So it's a 6x cubed over 3 minus 3x squared over 2 plus c. Okay, so that's that one. It was just 1 mark for each part, I think. You had to deduct 1 if you didn't have a plus c. Okay, part 2. Find the area of the region enclosed between that. So essentially, you're finding the integral between 2 and 1 of that function. 6x squared minus 3x. But you've already integrated this, so you know that that's... Oh, I didn't simplify that one before. Sorry. Ideally, you would have then simplified this to be 2x cubed minus 3x squared over 2 plus c, because 6 over 3 is 2. Right, so you've already integrated that, so you've got 2x cubed minus 3x squared over 2. And then remember, you don't need the c for this bit. You are substituting in 2 and 1. So you've got 2 lots of 2 cubed minus 3 lots of 2 squared. Oops. Over 2. Subtract 2 lots of 1 cubed minus 3 lots of 1 squared over 2. So 2 cubed is 8, multiplied by 2 is 16. 2 squared is 4, multiplied by 3 is 12, divided by 2 is 6. 1 cubed is 1, multiplied by 2, and then 1 squared is 1, minus 2. And so you've got 10, subtract 2, take away 1.5 is a half, so that's 9 and a half, however you put that. Alright, so we've been given the derivative, and they've asked us to find the function. So we know we're going to be integrating. Oh, I've got this pen's rubbish, I'm sorry. Okay, so we're trying to find the integral, so we know 6x cubed over 3 minus 5x plus c. That simplifies to be 2x cubed minus 5x plus c. But they've given us this additional information that allows us to find c. So we substitute x as 2, and so the function is -3. So we say -3 equals 2 lots of 2 cubed minus 5 lots of 2 plus c. So 2 cubed is 8, multiplied by 2 is 16. 10 plus c. Oops, so it's -3 equals 16, take away 10 is 6. And then so c is -9, so our function is, lost it, 2x cubed minus 5x minus 9. God. Okay. Alright, so they've given us the first derivative, and they want us to find the second derivative. So we're just differentiating. So you've got to remember what you're doing. So this is why the power comes in front. So that's 6x, and we take 1 off the power, minus 2k. Okay, and then obviously the -9 drops. So it's the power comes in front, take 1 off the power, and if it's just x, which it was in this case, it's just whatever is in front of it. So that was the minus 2k. Okay, so that's A. B, the graph has a point of inflection when x is 1. So points of inflection happen when that derivative is equal to 0. So we're going to say that 6 minus 2k equals 0. So 6 equals 2k, and 6 over 2 equals k, so k is 3. Oops, missed total vital point. This is so not the derivative. It's 6x minus 2k equals 0. Apologies. It has an point inflection when x is 1, so then this here becomes 6 minus 2k equals 0. That's my heart. Got the right answer, I just made a mistake. Oops. So, and then this then goes to that. So k is 3. Find f dash negative 2. So what was f dash? 3x. Oh my gosh. Okay, let me copy this. But we know k is 3. We just worked out that k was 3. What they told us it was. So we've got 3 lots x squared minus 6x minus 9. So that's the f dash x. And now we know we need to substitute negative 2. That's negative 2 squared minus 6 lots of negative 2 minus 9. So negative 2 squared is 4. Multiplied by 3 is 12. Negative 2 multiplied by negative 6 is plus 12 minus 9. So it's 24 minus 9 is, oh my gosh, 15. Okay. Right, okay, if the derivative of something is equal to 0, it means it's a maximum or a minimum or a point of inflection. Okay, so we know that. So they want to say we need to show that it's got a local maximum when x is negative 1. Now, remember, one of our tests for maximum and minimum points was the second derivative test. And we've worked out, didn't they tell us the second derivative? No. So we can find the second derivative. Okay, so we know that the first derivative is this. So the second derivative, yeah, didn't we find the first? Oh, yeah, we found the second derivative early on. 6x minus 2k. So the second derivative is 6x minus 2 lots of 3, because k was 3. So that's 6x minus 6. So that's the second derivative. So to find the nature of the turning point, we substitute negative 1 in. So we've got 6 lots of negative 1. Oh, 6. So 6 lots of negative 1 is negative 6. So that's negative 12. Now, since this value is negative, it means it's a maximum point. Okay, since double dash x is negative, it's a maximum point. So there we go. We have shown that it's a maximum. Alright, so now we're onto the calculator. So you should be using your calculator now because it says you're allowed to. Particle moves, and the values of t when a is 0. So what they're saying is that the value of a is 0. So 3t squared minus 42t plus 8 is equal to 0. It's the calculator part. So we're going to use our calculator. So we go to Polysmalt, apps, Polysmalt. We are solving a polynomial. So it's 2, yep. Oh. And so our first value is 3. Oops, didn't want to do that. So our first value is 3. And then negative 14, and then 8. Alright, 3, negative 14, and 8. And solve. So we've got 4, so t is 4, or 2/3. Right, almost missed this question. So when t is equal to the velocity is 3. Okay, so we need to find an expression for the velocity. So they've given us the acceleration, so we know that the velocity is the integral of the acceleration. So velocity is the integral of it's a blooming question. Right, we can use one of the papers. So 3t squared minus 14t plus 8. So we're going to find the integral of that. So that's 3t cubed over 3 minus 14t squared over 2 plus 8t plus c. So that becomes t cubed minus 7t squared plus 8t plus c. So that's the velocity. But they told us that when t is 0, the velocity is 3. So this is 3 when this is 0. So c is 3. So our expression is t cubed minus 7t squared plus 8t plus 3. Alright, next one. Here's our expression. So x-intercept. So we know the x-intercepts happen when y is 0. So if we're trying to find p, then we're going to solve that this is equal to 0. So again, it's the calc paper, so we put it in our calc. So we are, well, you've got different options here. I'm actually going to put it in this one. Oh, what am I doing? Main. So it's a root finder, but this time the order is 4. Okay, so we've got an order 4. So the first value is negative 0.5. Oops. Negative 0.5. And there is no 3, so that's a 0. And then it's a 3 in front of the x squared, and then a 2 in front of the x, and then a nothing else. So it's at 2.73, and let me snip this because that's easier. So here are my solutions. Obviously, they've only shown us the positive x-axis. So one of them was 0, which they told us, and the other one therefore must be, so p must be 2.73 to 3 sig fig. 5b, write down the coordinates of the A. What is A? A is the maximum point. So maximum points occur when the derivative is equal to 0. So what we're going to do is we're going to differentiate this and put it equal to 0. So we've got 4 lots of negative 0.5x to the 3 plus 6x plus 2. So that's the derivative. So 4 lots of negative 0.5 is negative 2x squared cubed. Sorry. Oh no, it's cubed. Plus 6x plus 2. So that's our derivative. That's equal to 0 for maximum and minimum points. So we're going to find out when that is equal to 0. So we're going to go to actually we can just probably use this and say that it's 0 here. Oh right, okay. Damn it. Alright, so we need to get to main, finder. We're going to go back to power of 3. So it's, what was it? Negative 2 x cubed, then there's no x squared, then it's 6, and then 2. I'm going to solve that, and we're going to snip it. Hey! So obviously these two values are negative and we're only in the positive, so x has a value of 1.88, and then we're going to substitute that into the expression to find y. So we're going to just go for out of here. So the expression was 0.5 brackets 1.88. Oh, bottoms, it's negative. Negative 8 to the power 4 plus 3 bracket 1.88 bracket to the power 2 plus 2 bracket 1.88 gives us 8.12. So that's the coordinates of that.